Por el camino del desierto, el viento me despeina, suave aroma de colita, no nada del área. Ella estaba a la entrada y la campana.
Bowling is a social game that has been played for thousands of years, with the earliest versions of the game dating back to ancient Egypt. The most common version of the game is played along an oiled wooden alley where players must roll a 10 to 16 pound ball down the lane, attempting to knock over 10 wooden pins found at the end. Our presentation will hopefully give all of you some insight into the various aspects of physics found in the game of bowling. A ball thrown down the lane will slow down over its course. The main cause of this is friction. The magnitude of friction between the bowling ball and the bowling lane depends on what the surfaces are made of and the amount of oil on the lane, if there is any at all, and the mass of the ball. Some lanes will have no conditioning on it at all, while others will have oil placed to a certain degree on different areas of the lane. As the bowling ball travels down the lane, the friction between the ball and the boards will slow it down. The composition of the oil, where it is more dense on the lane, will have a different effect on the ball as it travels along the lane. The more oil that is laid down, the less friction there is between the ball and the lane surface. The less friction, the harder it is for the bowler to send the ball in a curved path imparted by the spin that the bowler puts on the ball at the instance of release.
What is gravity? The value of gravity, g, is 32 feet per second squared, or 9.8 meters per second squared. This value is constant, which means that all objects fall to the Earth at the same rate of acceleration, no matter how much they weigh. There is some slight variation in the value for g depending on where on Earth you are located. What is center of gravity? COG. The center of gravity, or the COG, is the point at which gravity can be considered to act. In most cases, with uniform gravity, it is equal to the center of mass. The COG is not always within the object, as in the case of unusually shaped objects like a bowling pin. Bowling pins have a low center of gravity due to their shape, which make them more stable. The center of gravity of a bowling ball is not always in the absolute middle of the ball. The position of the center of gravity is usually indicated by the position of the logo or punch mark on the surface of the ball.
To begin, there are simple dynamics of the ball and the pins, angles of impact, and deflection. When you start out bowling with house balls, which are solid cast plastic, the correlation of the billiards examples we all learned in basic science are very clear. Roll the ball straight, hit the pocket at a specific angle with enough force, and the resulting succession of impacts will knock everything down. Most higher grade bowling balls come with guidelines as how to drill the finger holes to achieve different results in play, based upon what kind of bowler you are. There are simple lane conditions and the mathematics of the curves to be used to deliver the ball to the pin pocket. Did you know that the lanes are oiled up about 10 feet from the pins, and then they are dry the rest of the way? That's how pros achieve those astounding last-minute breaks that tear into the pins.
Gravitational potential energy. Depending on the height from which the bowler drops the bowling ball, the ball will have a certain amount of potential energy. If the bowler bowls with a straight ball, the potential energy of the ball will not affect their game very much. Thus, it is in the straight ball bowler's best interest to keep the ball as close to the lane as possible upon release. Bowlers who bowl with a hook ball have even more at stake. The potential energy the ball has upon release, the longer it will bounce as it travels down the lane. This translates into less opportunity for a hook ball to catch friction against the lane. Remember, the horizontal velocity is independent of the vertical velocity. Hence, assuming the ball is always thrown with a force parallel to the horizon, the ball will take some amount of energy and time to reach the pins, regardless of how much time it spends airborne.
Direction of initial force. For maximum impact, the bowler must release the ball with a force perfectly parallel to the horizon. Since the horizontal velocity is independent of the vertical velocity, any force that is not parallel to the horizon is wasting energy in the vertical direction. Because there is no benefit to bouncing the ball, all energy should be spent in the horizontal direction. The horizontal kinetic energy that remains after the ball has traveled down the lane is the energy that will be used to collide with the pins, so the bowler needs to make it count. The magnitude of the forces exerted in the horizontal and vertical directions can be calculated using trigonometry.
The total magnitude of the force multiplied by the cosine of its angle with the horizon will calculate the horizontal force. Conversely, the total magnitude of the force multiplied by the sine of its angle with the horizon will calculate the vertical force.
Friction, hook balls, and direction impact. When a bowler balls with a hook ball, they are taking advantage of friction. A hook ball is when the ball goes about 2/3 of the way down the lane before curving into the pins. Don't bowl against people who do this. They are usually very good. The lanes are oiled, producing a small coefficient of kinetic friction. Therefore, it takes a long time and a lot of torque on the ball to cause it to curve into the pins. The ball accelerates to the left or right as it catches what little friction it can. The reason most good bowlers bowl with a hook ball boils down to the direction of the collision with the pins. Throwing the ball straight down the lane, while easy to do, does not distribute the impact efficiently. Once in a while, a straight ball bowler will get lucky and put a large X on this score chart, but more often than not, they will get a split instead. It's best for the ball to collide between the head pin and one of its neighboring pins at roughly a 30-degree angle to distribute the force of impact evenly throughout the arrangement of pins. Anytime one group of pins flies around in a violent motions while others stand still, as if nailed to the ground, this tells the bowler that they did not distribute the force of impact efficiently.
Pin action. Pin action, also known as pins erupting into chaos, is caused by elastic collisions. Once the bowling ball hits some pins, it sends those pins into more pins, those pins into more pins, and so on. But it doesn't stop there. The pins also bounce off one another, sending them in every conceivable direction, sometimes right back in the direction the ball came, until they have all fallen down, disappeared, or run out of kinetic energy. Because of this kinetic insanity, strikes are almost as unique as snowflakes, but twice as pretty. Each interaction between two or more pins and/or the ball is an elastic collision. The pins bounce against one another because their momentum is conserved during the collisions. We hope that you all enjoyed our presentation and that now you have a better understanding of the importance of physics in the game of bowling. Thanks.
One ball, one strike, $1 million.
And the loser gets nothing.